Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about element of earth magnetic field. Earth possesses magnetic field. The magnetic field is a vector quantity. It have both magnitude and direction. So, the magnetic field at any point of the earth have magnitude and direction. To specify the direction and magnitude of the earth magnetic field at any point, three elements has to consider. One is declination, the second one is inclination or angle of thing, and the third one is horizontal component of earth magnetic field. Okay, so these three components are called as element of the earth magnetic field. Okay, so the first one we are going to discuss now, that is declination. Okay, so I am going to consider a sphere, that is earth, and a line which is joining between the geographic north and south. This is the geographic north and this is the geographic south. It is also called as true north and true south. Okay, in the earth containing latitude circle and longitudinal circle. The latitude circles are the parallel circle in the east-west direction, like this direction. Longitudinal circles are parallel circles in the north-south direction, like this circles. Okay, I am going to draw a vertical plane which contain the longitudinal circle and the axis of rotation of the earth, like this. This vertical plane is called as geographic meridian. Okay, then and consider the axis of the earth magnetic dipole. Okay, and I am going to draw a vertical plane containing this magnetic axis. That plane is called as the magnetic meridian. Okay, like this. This is the magnetic meridian. Okay, the angle between the geographic meridian and the magnetic meridian is declination. Okay, so what is declination? We can write here. Okay, so this diagram more clearly I will draw now. This is a geographic meridian, is a vertical plane that will split the earth like this. That means you consider an apple, the apple cut like this. So I will draw like this. This is the geographic meridian. Okay, then now I will show you the magnetic meridian. Okay, magnetic meridian. This plane is a magnetic meridian. This angle between them. Okay, angle between them is the declination. Okay, this magnetic meridian, how you will find out? The magnetic meridian can be found out by using a horizontal freedom compass, otherwise normal compass. What is meant by horizontal freedom compass? Horizontal freedom compass means that compass having a needle. That needle can free to rotate in a horizontal plane like this. If you consider this is the north pole and this is the south pole, this compass needle can rotate like this in a vertical axis. Okay, so you place the horizontal compass at a particular point, that will show the magnetic meridian at that point. Okay, from that we can get the declination also. By using a horizontal compass we can find out the declination. Okay, how much is the angle with the geographic meridian? Okay, so this declination value is vary from place to place. Okay, so this declination value, we can use it for finding the location of a particular place and the direction to that particular place. So this is the way the people are using the compass for getting the direction and the location of a particular point in the earth. Okay, this declination value increases when go to the poles. So we can say that the declination is smaller. Declination is smaller in equator and greater in poles. Greater in poles is in poles. Okay, this is about the declination. Okay, then next we will see the inclination or angle of dip. I took a vertical freedom compass. What is meant by vertical freedom compass? You look at like this. Previously, this is a horizontal freedom compass needle. Okay, if we will consider it as a vertical freedom, how it will rotate? Like this it will rotate. In the vertical plane it will rotate. Horizontal freedom means like this it will rotate. Vertical freedom means like this it will rotate. Okay, so now I am going to consider a vertical freedom compass. Okay, so the vertical freedom compass is like this. Okay, there is a horizontal line which is passing through it. Okay, or you can take it as another device, that is a dip circle. The dip circle is similar to vertical freedom compass. I will show you how the dip circle. Dip circle means like this. Okay, then it consists of a magnetic needle like this, and here angle is 90, then on 0, and here it is 0, and here it is 90. Okay, so from there is a horizontal line. Okay, and here there is a stand there given like this. Okay, this is dip circle. Okay, this is a vertical freedom compass. Okay, two are same thing. Okay, then so to understand the inclination or dip, we are using this vertical freedom compass or dip circle. Okay, then so I am taking this vertical freedom compass to northern hemisphere. That means if you consider the earth like this, okay, earth like this is the north pole, here is the south pole. Okay, this is the northern hemisphere. In the northern hemisphere, this magnetic needle north pole dip down by an angle with horizontal. Okay, so like this it will shows. This is the angle. This dip angle is called as inclination. Okay, and the similar way, if you take this vertical freedom compass to the south hemisphere, the south pole dip down. The south pole dip down by an angle with the horizontal. That is this angle. That angle is called as the inclination. So inclination is the angle dip down by the vertical freedom compass north pole in the northern hemisphere or the south pole in the southern hemisphere. Okay, this vertical freedom compass gives the total magnetic field at a particular point. Okay, so if I will keep this vertical freedom compass at this place, it will show the total magnetic field direction at this point. Okay, so if I place here this point, I will get the total magnetic field direction like this. I will get B. Okay, then this total magnetic field is making an angle with the surface, or we can say with the horizontal. This angle is inclination. So we have two definition is there. Any definition you can use. Okay. So what is inclination? Inclination is the inclination. Okay. This is about the angle of dip or inclination. Why it is called as angle of dip? Did you got it? Is because this vertical freedom compass is dipped down, so that it is called as angle of dip. Okay. This is about the inclination. Okay. Now we will see the horizontal component of Earth magnetic field, that is represented by H. This is the Earth, and this is the axis of rotation of the Earth. This side, this is the geographic north pole, and this side is the geographic south pole. Okay, I am going to find out magnetic field at a point on the Earth, that is the P point. I am going to find out the magnetic field. Okay, for that I am first going to draw a geographic meridian. Geographic meridian is a vertical plane which contains the longitude and the axis of rotation. So I am going to draw like this. Okay, this is the geographic meridian. Geographic meridian. Okay. Next I am going to draw magnetic meridian. For that I am placing a horizontal freedom compass at the point P. The compass shows the magnetic meridian. Okay, I got the magnetic meridian at this point P is like this. Okay, this is a magnetic meridian. Okay, then I am going to draw a tangent on the magnetic meridian. Like this, I will draw a tangent on the magnetic meridian, and I am going to draw a tangent on the geographic meridian also, like this. Okay, then I consider a vertical plane in the magnetic meridian. First I am going to consider a vertical plane in the magnetic meridian. Okay, like this I am going to consider. Okay, this axis of rotation I am going to erase. Like this. Okay, then I am going to consider another vertical plane. Here will be also there. Okay, this is a vertical plane. Okay, clear? So, you look at here. This is the tangent on the geographic meridian, and this is the tangent on the magnetic meridian. Okay, the angle between these two is the declination. Okay, this I am going to draw here. Okay, look at here. Okay, this is the tangent on the magnetic meridian. Okay, then next. Okay, then you see this is the tangent on the geographic meridian. The angle between these two is declination. Okay, clear. Then now I am going to take a dip circle and I place it at the point P. The dip circle gives the total magnetic field at the point. Okay, I got the total magnetic field. I got the total magnetic field is like this direction. Okay, so I am going to draw here. This way I got the total magnetic field. That I am represented as B. B is the total magnetic field of the Earth. Okay, then so the total magnetic field of the Earth and the horizontal make an angle is angle of inclination. That is also I can get from the dip circle. How much the north pole dip by horizontal. Okay, because it is a northern hemisphere, so how much is the north pole dip down by horizontal? Okay, that is the angle of inclination. Okay, this angle of inclination is the angle between the horizontal and the total magnetic field. Okay, based on this angle of inclination and the magnetic field, I can split this magnetic field into two components. like this. You see, one component is along the horizontal direction, that is here represented as H, and another is a component in the vertical direction, that is Z. Okay, so now you see this HE is the horizontal component of the earth magnetic field, and that we can write it as BE cos I is an inclination. And what about the vertical component? Vertical component is equal to BE sin I. Okay, then so now we got all the thing we got. Okay, horizontal component we got declination, we got inclination. All the three elements of the earth magnetic field we got. Okay, then now we can define the magnetic field magnitude and direction at any point. I am consider the point P. So there magnetic field of the earth magnitude and direction I am going to find it. Okay, so the magnetic field of the earth is how much? HE plus B. Sorry, HE plus ZE. Okay, then the magnitude, how we can find out? Magnitude is equal to the square root of HE square plus ZE square. Okay, this is the magnitude of magnetic field. Okay, then what about the direction? The direction is this is the total magnetic field. This total magnetic field is make an angle I with the horizontal. This I will get from the deep circle, or from the horizontal component also we can find out. This is, you take it as equation 2, and this is 1. Take 2 by 1. Then what you will get? That is ZD by HE is equal to BE sin I divided by BE cos I. This BE cancels, so tan I is equal to ZD by HE. Okay, ZD divided by HE. Okay, from this I is equal to tan inverse of ZD divided by HE. Okay, clear? Then this way we can find out the direction and magnitude of the magnetic field.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like